Hey, welcome back to Data Science for Humans. I'm Elias Perinin, and let's continue where we left off. We were just about to combine data frames. If you remember from our last video, we just finished cleaning up two data files, got them into a similar format, and now we're ready to actually combine them together into one data file so we can run statistical analysis on them. Let's continue. Back in Spider, we'll see that we've got our two data frames and two different variables, data 2428 and data 2429. Notice how we've got them. If we open up our two variable explorers, notice how we've got fiscal year and region in the same format. Now, we've been glossing over this extra column called index, and I hinted at it during our first video. What this index is basically it's a label for every single row. It's a way to uniquely identify every single row in our file or organize all of our data frame. In order to combine our data frames together, we're going to need to have common indexes so that pandas can do the work for us. In other words, what we'll be able to do is if we index our file by fiscal year and region, we'll be able to join data 2428 and data 2429 together. So in other words, we'll be able to produce a row that has for the central region, for the community admission type, compared with each of the different categories of offenses in our data 2429 data frame. So how do we re-index? Well, look at that. I already gave away the concept that we're going to cover. What we're going to do is re-index our data frames, because Pandas gives us an automatic data frame index for free, which is basically a number that starts at 0 and increments by 1 for every single row in the data frame. So the common index that we've selected is our fiscal year and our region. So let's give both our data frames a common index. And again, I'm going to comment out line 36 for now, our data 2429.2CSV. So how do we do that? We say data 2428 equals data 2428.set underscore index, and we pass in an array of strings, fiscal year and region. Let's run that. Notice already in the variable explorer how this data frame has changed. We see two column names only, admission type and count. If we double click on this, we see that our index column has changed to the fiscal year and the region. Isn't that interesting? Let's do the same thing for data 2429. So data 2429 equals data 2429.set index. And we'll do the same thing, fiscal year and region. And again, we see rank, category, and count as our three columns in our data 2429 data frame, and it's now indexed by fiscal year and by region. Now, we're going to combine our two data frames. They have common indexes. That means they can be joined together. Check this out. We're going to create a new data frame called combined. We'll set it equal to data 2428.join. And in here, we'll pass in data 2429. Let's run it. Oh no, we have an error. Type error, less than sign is not supported between instances of float and str. What's going on here? Well, if we take another look at data 2428, you'll notice something. If we go to the very bottom, we'll see we've got two problems here. We have our final row, we have this entirely blank row, but then we have another issue. Look at our fiscal year. It is a string type. It's in the quotation marks. Look at data 2429. It is also string type. So we have an issue with our final row. This should not be not a number. We need to drop this not a number row, because what Pandas is trying to do is compare that not a number to a string value, and that's just not a thing that's just not an option. So how do we drop this extra row that has NA? Well, check this out. We're going to write another piece of code. We're going to say data 2428 equals data 2428.drop NA. And we're going to tell this how to drop NA. We want to say that if all the elements in the row are not a number, drop that entire row. So now we'll run it. And look at this. We get a new error. It says value error. Columns overlap, but no suffix specified. Why is that? Both our data frames have a column that is named count. We can't have that. Each column needs to have a unique name, which means we need to go back to where we renamed our columns and give these unique names. So, our first, in data 2428, we're going to rename columns count to count admissions. And then data 2429, we're going to rename count to count offenses. Or to count offense. And then finally, we'll need to update any calls we make to count in our data frames with these new names. Notice how I'm doing that right now. Now we can join these data frames together. And by running this file, notice we've got a brand new data frame. So we see we can match up each of the admission types with each category of offense. Now we're ready to run our statistical analysis. But more importantly, we can now write this file combined to CSV, combined 24282429.csv. And this time, we're going to keep the index. Let's look at that file. Here we go. Our combined file is ready for analysis. You could stop here and take this file into Excel, into Tableau, into Power BI, into another analysis tool, and actually start doing some very rich graphical analysis on this file. Next time, we'll look at how you can use Python to run some regression analysis against this combined file.